Hi, today's lesson is about the difference between kinetic energy and momentum. But before we get to that, I want to tell you a story. So, there didn't used to be a difference between science and art. Thinkers used to refer to themselves as natural philosophers, people who just studied nature, and they did that through both science and philosophy. And for a while, they had a big argument, back in this sort of time of Newton and Leibniz, about this idea of motive force. Because they'd noticed that there were things that seemed to put force into the world. Just have a think, what do you think might be the things that Newton and Leibniz thought put force into the world, the things that pushed things? Well, the answer was people and animals. They saw that somehow they were able to move things and move things around, everything else sort of stayed static without them. And they used this, interestingly, as discovery of the soul. They thought they'd found what souls were, because humans and animals were able to do something that rocks couldn't. Interestingly, in one of his books, Newton did say, "The cork flew off the top of my fermenting beer, and this is a problem we should return to," but it didn't seem to worry them unduly. At the time, they thought that humans and animals pushed things in the world, and then they'd sort of slowly come to a stop, in the way that when you roll a ball now, it will roll along the floor for a bit and then kind of just come to an end. And so they thought that force was sort of draining out of the world, and that humans and animals put it back in. It's a nice idea. They then got into a big argument because they started to measure motive force, and they didn't have an idea of energy or conservation of energy or momentum or anything like that. And they kept coming back to these two equations. Ignore the half for now. mv squared and mv, mass times velocity squared and mass times velocity. And they both seemed to be important, but no one could really work out why. Today we've got names for them, momentum and kinetic energy, but I think that we struggle often to separate them out. We struggle to realise what the difference is. So I'm going to give you 30 seconds now. See if you can come up in your mind with a description of what you think the difference is between kinetic energy and momentum. Tricky one, isn't it? There are words we use all the time without really thinking about what they mean. The way I like to describe it is as follows. Kinetic energy is a measure of how much of a mess something will make of you if it hits you. Momentum is a measure of how easy something is to stop. So let's have a look at these. First of all, just spend a moment. Where does the half come from in kinetic energy? Why do you need to put the half in there? Just spend a moment and think about that. It's just to make the units work. It's entirely arbitrary. If you put the half in, your answer comes out in joules. Simple as that. It's not real in the same way the mass and the velocity are. So just always remember that. Some things are real, properties of the universe. Some things we just put in to make the numbers work. And that's what that half is. Anyway, what's the difference? Well, kinetic energy has got a much bigger velocity component, whereas momentum, the mass and the velocity components are equal. So I want you to imagine a bullet, low mass, very high velocity, and a truck, huge mass, medium velocity. In fact, we'll make the truck going at like 10 meters per second, so it's not even going that fast. So, the bullet, huge amounts of kinetic energy, small momentum, will make a massive mess of you if it smashes into you. You don't want to be hit by a bullet, bits of you flying out everywhere. But crucially, you will stop it. The bullet will stop, because its low momentum means it will stop. Yeah? On the other hand, the truck, high momentum, low kinetic energy, can bump into you, and you'll be like, oh, you know, and it won't actually kill you, but you're not going to stop a truck, are you? Because it's got all this momentum and it keeps moving forward. So that's how I always like to think of the difference between the two. And if you can really conceptualise of that and really think about that carefully, then part of your homework today is just spend a minute or two and make sure, do I really understand it? And to make sure, you could go and explain it to someone else. Yeah? As Einstein said, you only really understand something when you can explain it to your grandmother. So this one, the difference between kinetic energy and momentum, I find is a good one to go and try explaining to someone else. The other thing, which of these is conserved? This one, momentum, not kinetic energy. We think of energy being conserved all the time, but actually kinetic energy can turn into any type of energy you want. It can even sometimes turn into mass. But momentum, that one's pretty in-baked. That one is pretty deep in the universe. Momentum is always conserved, which is another interesting difference between them. Can anyone remember what's the name of a type of collision when kinetic energy is conserved? It's an elastic collision. So only in elastic collisions is kinetic energy conserved. And elastic collisions aren't even real. They're just a theoretical thing we pretend. Momentum is always conserved. Okay. Some questions down below. See you Monday.